So this one says we want the area of the region enclosed by these two graphs. So we've got y equals x, and then we've got this graph, which is going to be a parabola. So let me go ahead and draw a picture of this. Start plugging in some numbers. I always just start with 0. That's a good place to start. If we plug in 0 to this, we are going to get 3. And if we plug in 1 minus 3, that'll be -2, plus 3 would be 1. I really just need to find where it turns around since I know it's going to be a parabola. All right, I'm plugging in 2. That's going to give us 4. Minus 6 would be -2. Plus 3 would be 1. So that's where it turns around. And so I know I'm going to have this other point symmetric up here at 3. So it's going to do something like this. And then the other graph was just y equals x. So that's going to go through the origin and have a slope of 1. So do something like that. So this is the area that we are trying to find. And so our integral is going to be from here to here, where the two intersections are. So this intersection was at 1, and this intersection is at 3. So we're going to integrate from 1 to 3, and it's the upper graph minus the lower graph. So the upper graph is the line, so that one's x, minus the parabola. So I want to subtract this whole thing. So I'm just going to go ahead and distribute the negative signs through that. So that'll be minus x squared plus 3x minus 3 dx. And then actually I'm going to also go ahead and combine the like terms first. X and 3x will give me 4x. And then the antiderivative is going to be -1/3 x cubed plus 2x squared minus 3x, and we will evaluate from 1 to 3. So upper boundary minus lower boundary. If I plug in the 3 cubed would be 27. 1/3 of that would be 9, but it is negative, so -9 plus 3 squared would be 9, double that is 18, and then minus 3 times 3 is 9. So that is the upper boundary minus the lower boundary. So that'll be -1/3, and then plus 2, and then minus 3. This would be a non-calculator question, so we're going to have to get through this and simplify it in order to be able to pick one of these answers. This first part's kind of nice. This is just going to be 0 for all of this. -9 and -9 and then +18. That'll just be 0. I'm going to distribute the negative sign through the rest of this. Everything's just going to basically flip-flop its sign. So this would be 1/3 plus 1, which would be 4/3. And so that one is C. Number 2, they're just asking us to set this up, so we're not going to have to actually work it out, which is kind of nice. We would want to do the integral from this first intersection point, so that is A, until this intersection point, which they have labeled as C. So integral from A to C, and then it's the upper graph minus the lower graph. So the one on top is f of x, and then the lower one is g of x. So we're looking for the choice that looks like that, and that one is D. All right, number 3, we want the area between this graph and the x-axis from 1 to 2. So the x-axis is just the line y equals 0. So we tend to kind of ignore that. It would be this graph minus nothing, and integrated from 1 to 2. So integral from 1 to 2 of this equation. So that antiderivative is going to be x to the 4th plus 2x, such that 1 to 2 And we're going to do upper boundary minus lower boundary. So plugging in 2 to the 4th would be 16, plus 2 times 2 would be 4, minus, and then plugging in 1, that'll give us 1 plus 2. So this would be 20 minus 3, so 17 for that one, and so that is D. All right, this one I know I am going to need a calculator for because all of the answer choices are all these crazy decimals. So anytime you see any choices like this where it's all, you know, to 3 decimal points, you know you're going to be allowed a calculator for that. So I'm going to go ahead and type these 2 equations in. I'm going to y equals, and I'm going to put the first one in y1 and then the second one in y2. And I'm going to start with Zoom 6. If we don't like that window, we can always change something else that's just Zoom standard. So there's the cubic graph, and then there's the line. So there's actually 2 areas that are enclosed by these. We've got this one teensy tiny little area right here, and then this bigger area here. So we're going to need to integrate from the very beginning of this first intersection all the way to the end where this other intersection is. So I'm going to calculate those intersections. So second trace, and then intersect. First curve, enter. Second curve, enter. You basically can't get those messed up because there's only 2 graphs. And for guess, I'm just going to move the cursor close to the first intersection and hit enter. And so that gives me 1. So our first intersection is here at 1. And then I need to find this one as well. So I'm going to calculate intersection, first curve, enter, second curve, enter. For guess, I'm just going to move the cursor closer to this one and hit enter, and it will give me that one instead. And so that one is 5. So the first intersection was 1, and the one over here is 5. So we want to integrate from 1 to 5. And I'm going to need to put an absolute value around it because for this little section, the cubic graph is on top and the line is underneath. And then for this bigger area section, the line is on top and the cubic graph is underneath. You could break it into 2 separate integrals and break it at this intersection here, but doing it all at once is less work. So that's the better way to do the problem. But if you put an absolute value around it, then it won't matter which way you subtract the function. So this is going to be absolute value of, I'm just going to take the cubic function first. So x cubed minus 8x squared plus 18x minus 5. And then minus the x plus 5. And that will give us the total for both of those areas. So we're integrating from 1 to 5. And I know it's usually upper graph minus lower graph, but if we put the absolute value around it, it won't matter which way we're subtracting that. So let me clear out of here and type in this integral. So absolute value, x to the third minus 8x squared plus 18x minus 5 minus parenthesis x plus 5, close parenthesis, dx. And then this may take a minute because the absolute value, oh no, it did it really quick. All right, 11.833. So that one is B. All right, number 5, this says the region bounded by the x-axis and the part of the graph of cosine between -2 and pi over 2 is separated into 2 regions by a line x equals k. Okay, let's take a look at that. First, let's graph cosine. Cosine starts here at 0, 1, and then it's going to wave in each direction. So here's pi over 2, here's negative pi over 2, and it's going to do something like this. And then it'll continue waving in each direction, but we're concerned with this part right here in the middle. It said the part of the graph of cosine, between cosine and the x-axis, between negative pi over 2 and pi over 2. So this is the portion that we want to look at. Now it says that that's being separated into two regions by the line x equals k. All right, so we're separating this here at some value k. And it says the area for the region from negative pi over 2 to k. So that would be this shaded part. It's saying that region is 3 times the area of the region that's bigger than k. So this little part here, this part I shaded is 3 times as big as this part. So it did not get split evenly in half. And then it says find k. All right, so let's write an integral for the area of the shaded region. That would be the integral from negative pi over 2 to k cosine x dx. So that would give me the area of the part that I have shaded, and that is 3 times the rest of the area, the part that I didn't shade here. So that would be 3 times the integral from k to pi over 2 of cosine of x dx. So that shaded area is 3 times what the rest of it would be worth. So we're going to have to work both of these out. It's going to be a good bit of writing, but it's going to be pretty redundant because they are the same function. Antiderivative of cosine is sine. And this one is from pi over 2 to k. And then same thing here, except there's a 3 out front. So this will be 3 sine of x from k to pi over 2. Oh, and I'm sorry, this one's negative. I apologize. So upper boundary minus lower boundaries. This is sine of k minus sine of negative pi over 2. All right, let me draw my unit circle. If we rotate backwards pi over 2, that's going to put us right here. And that is the point 0, negative 1. Sine is the y value, so that would be the negative 1. So this would be minus negative 1, so that's going to be plus 1. Equals. All right, here we're plugging in the upper boundary pi over 2. Okay, now we're rotating forwards pi over 2. That puts us right here. Again, sine is the y value, so that would be positive 1. And we're multiplying that by 3. So that would be 3 minus, and then plugging in k would be 3 sine of k. So getting our like terms together, I'm going to add this 3 sine of k over to the other side. So if I have 1 sine of k plus 3 sine of k, that's going to be 4 sine of k. And I'm going to subtract this 1 over to the right side. So 3 minus 1 will give me 2. Divide over the 4, 2/4 is going to reduce to be a half. And so we are looking for a place on our unit circle where sine is a half. Sine is the y value. So that would be this triangle where you have a 1/2 here, and then the other side would be a square root of 3 over 2. We don't necessarily need that so much. What we're looking for is this angle that goes across from a half. And so the angle that goes across from the 1/2 is pi over 6. And so we get k is pi over 6. So let me recap because that was a lot. We did the integral from negative pi over 2 to k, and then from k to pi over 2, except that one was 3 times as much. Then we did the antiderivatives. We evaluated upper boundary minus lower boundary, and then we solved for k. So that one is C. All right, number 6. We're using this graph right here. It says, which of the following represents the area? All right, so we are going to integrate from A to B, and then it's the upper graph minus the lower graph. So the upper graph is just d, that's just a constant function d, minus this lower graph is f of x, and then dx. So let me see which one matches that. Integral a to b, d minus f of x, that's going to be b. All right, number 7, the area enclosed by the graph of x squared plus 1 and y equals 5 is. All right, let me draw a picture of that. This is a parabola moved up 1 unit. So I'm going to go up 1 and put a point, and then I just want to get a few points on either side. So if we plug in 1, we're going to get 2. Same point on the other side since it's a parabola. And then if we plug in 2, we're going to get 5. So that will look like this. And then the line y equals 5, that's a constant function at 5. So this is the area that we are trying to find. And so we're going to integrate from this intersection to this intersection. This one is at -2, and this one is at +2. And it's upper graph minus lower graph. So the upper graph is that constant function at 5, minus the lower graph is the x squared plus 1. Now I need to subtract the whole thing, so I'm going to distribute the negative signs through that. So minus x squared minus 1. And then I'm just going to put the like terms together before I do the antiderivative. This will be negative x squared plus 4. And so that antiderivative is negative 1/3 x cubed plus 4x, such that -2 to 2. And we're going to do upper boundary minus lower boundary. So if I plug in 2 cubed is 8 times negative 1/3. So negative 8/3 plus 2 times 4 will be 8. Minus, and then plugging in -2. -2 cubed would be -8 times negative 1/3. So the negatives are going to cancel. That'll just be 8/3. And then 4 times -2 is -8. Now this would be non-calculator, so we've got to keep going here until we can get one of these answer choices. I'm going to distribute the negative. This first part is going to just stay the same. And then the whole numbers, we've got 8 plus 8, that'll be 16. Combining the thirds together, that would be minus 16/3. And so we need a common denominator of thirds. So 16 would be 48/3. 48 divided by 3 would equal 16. So that would be 48/3 minus 16/3, which, oh gosh, what would that be? 32/3. And so that one is D. So there are times when you're going to have to fight through those fractions without a calculator. A question like that would be on the non-calculator part. So free response is better in my opinion, because you could just stop here. You don't have to evaluate that down. But if it's multiple choice, you have to keep on going until you can, decide which answer choice it is. All right, and then 8 was a review question. Well, sort of. It's still about areas, but it's a review of the improper integrals. R is the region between this graph and the x-axis for everything bigger than 3. So that means from 3 onwards forever. And so that is going to be limit as b goes to infinity, integral from 3 to b of this function. So again, the issue is the infinity. We basically just stuck it outside and called it by another name. We just called it b instead. So then the antiderivative of e is itself. We're just going to need a -1/2 to adjust for the -2, such that 3 to b, and then it is going to be upper boundary minus lower boundary. So plugging in the upper boundary, it would be -1/2 e to the -2b. I'm going to bring that back down to the denominator. The negative exponent means it'll be in the denominator. So I'm going to put e to the 2b down there, minus, and then plugging in 3, this would be -1/2. So negatives are going to cancel. It'll be +1/2 e to the -6. Which actually, I should bring that down to the denominator too. That would be 1/2 e to the 6. And then the last step is to evaluate the limit. So as b goes to infinity. So if you imagine plugging in a really, really, really enormous number here, you get something like 1/1,000,000,000, which is super, super, super tiny. And so that goes to 0 for that first part. And then plus 1/2 e to the 6th. And so that is our answer, 1/2 e to the 6th. And so that one is A.